Okay. Good afternoon, everyone. Welcome to today's webinar organized by UNESCO Chair on Disaster Risk Reduction and Resilience Engineering. My name is Xiang Li. I'm a research fellow working affiliated with this UNESCO Chair. Today, we're very pleased to have Professor Qiuchen Liu from UCL to share her research on the resilience and the digital twins. But before we begin today's webinar, I'd like to advertise our next event, which will take place on the 7th of May. The topic would be the Cambridge Co-Creation Approach, Tools for Systems Change and Impact, which will be given by Professor Nasir Habib from the University of Cambridge. So you can refer to our website for more information. We also share the registration link with you through email. So please have a look at your email then. Next, move back to today's webinar. The topic today is towards resilient cities through digital coupled human nature and infrastructure systems, i.e. chains, which is very interesting topic. Please allow me to introduce the speaker today. Professor Qiuchen Liu is a professor in digital built asset management at the Butler School of Sustainable Construction, University College London, and a globally recognized scholar in digital innovation for the built environment. Her research focuses on the integration of digital twins, artificial intelligence, and informatics to support the development of smart, sustainable, and resilient city systems in the context of climate change. Professor Liu has secured over £1.4 million as PI or co-PI and contributed to a project over £3.4 million as a co-I funded by EPSRC, Royal Academy of Engineering, British Standards Institution, etc. She awarded the Royal Academy of Engineering Leverhulme Trust Research Fellowship in 2024 to 2025, one of the most prestigious awards in the UK. We support the most talented researchers across engineering fields and awarded only 7 fellowships yearly. She also awarded the Integrated Research on Disaster Risk, i.e. IRDR, Young Scientist Scheme by the UNDR, where limited outstanding researchers can be awarded globally every 5 years. Within the domain of digital built environment, she has authored more than 75 peer-reviewed publications and 4 books. Moreover, Professor Liu acted as the international collaboration coordinator of the European Group for Intelligent Computing in Engineering, i.e. ICE, and a visiting fellow at the University of Cambridge, and leads international collaborations across Europe and Asia. She acted as the guest editors and reviewers of multiple RCI indexed journals, including Cities and Advanced Engineering Informatics. Without further ado, I will pass the microphone to Professor Liu. Let me stop sharing. Okay, Professor Liu, the floor is yours, please.
Thank you so much for the introduction. I will share my screen. Can you see my screen?
Yes.
Okay. Thank you so much for the introductions and all kind invitations, and I have the opportunities, very great and valuable opportunities to express my research and for the past around 10 years. So for the last 2 years, I'm always think about how to give a map and how to give my research definitions, and also how to give directions for my future research, especially aligned with my groups and also aligned what is current, the most important topic. So combine all my 10 years research journey. So I would like to deliver this speak as towards resilient cities through the digital coupled human nature infrastructure systems. I call it the chain systems. So currently I am I'm the professor at the University College London, and also like the IRDR Young Scientists supported by the different institutes around the world. And I will cover my research in different perspectives, including a whole research map of my research journey, including how to, from the model perspective, how to establish the multi-modal data-driven digital twin, and how to use the digital twins to build a link and the bidirectional feedback loops with human and digital twins, and then how to basic on the chain systems and digital twins towards the resilient cities, and then aligned with SDGs, the current climate change and also SDG scopes. So how to towards a global perspective research. So I already have very detailed introductions from Dr. Lee, but I want to like briefly introduce myself. And I graduated from a PhD graduate University of Hong Kong and focus on the computing in civil engineering. That is how my research started. And also during the past 10 years, I won many different awards from the when I was in Cambridge and also at UCL, such as the Royal Academy of Engineering Level Home Trust Fellowships and also different fellowships from different organizations, and I try to support the resilient cities and from different city systems. So I will cover it one system by one systems, such as I will start from the transportation systems and to other city systems, and finally achieve my research ambitions, which is called One City Concepts. And then also got many recommendations around the world and published many different books, such as my most proud one is the digital twin in the built environment, and I cover it from the theory to implementations, and also deliver several speeches around the world and I try to build a link and collaborations around the world. So it is my great opportunities that I can be here and try to set different discussions and also possible collaborations in the future. So come to my research experience, and I always focus on two scientific questions. So how, no matter is from the digital twin perspective or from the nature or infrastructure perspective, I also think about three perspectives. So the human, infrastructure, and nature, how these three systems can build affirmation mechanisms and to become a kind of coupled relationship around the human nature infrastructure systems, and which can be supported by different technologies. I'm from the perspective of digital twin and AI, but there are a lot of physics and also mathematics problems behind it. So I'm always focused on how to build the mechanisms of copying the relationships among the human nature and infrastructure systems, and then develop new systems, new method, new algorithms for the chance systems towards resilient cities. This is my key scientific questions cover the whole research journey. And for my the whole research journey, I also covered from the three steps. So first one, when we talk about the city systems, we actually covered many different perspectives, such as the transportations, such as the buildings, such as the, for instance, basic on the Professor Michael theory, because currently I actually work close with him and all my research basic on his theory. Based on his theory, there is 6 functional systems, and the 6 functional systems from the buildings, from the people, from the transportations, from the different perspective, how to create the digital twin for them from different infrastructure systems, such as transportation, such as building, and then how to keep updated informations with the time passing by, especially during the operational maintenance phases. And the second, so when we talk about the city, we cannot ignore the people system. So how to build relationships with people and the digital twins. If we didn't talk about people, there is no true digital twins will be existed. That will be like digital shuttering or beam or any other different models. But how to build a link especially bi-directional relationship between the people and also the digital twin is my key aspect. And I built this 5-layer multi-scale digital twin theory and also aligned with the stakeholder requirements and data requirements transfer systems to create these whole systems support the fed people systems and build the foundations for the digital twin establishment. So basic on the modeling aspect. So dynamic and also static digital twinning systems, and also basic on the people and feed digital twin theories and to support the future, the resilient cities and basic on the chain systems and also the digital twins and further support SDGs such as the sustainable cities and communities and climate actions, especially the current dramatic climate change ages. So for the first part, how to establish the digital twins. So my approach is there are many different approaches. I know that there are many very excellent researchers only focus on this aspect, such as use the point cloud, such as use the different data resources. So my ways is to combine some very convenient or easy collected data resources, such as my mainly data resources will from the CD images, which is collected by the handheld cameras, and also videos collected by the phones or the handheld cameras, combined with the very easy collected like this kind of data resources to achieve the practical, efficient, economy, and accurate multi-modal data driven digital twinning approaches and generated the semantic, accurate, and information-rich digital twins. So I mainly cover two aspects. So the first one is develop the novel image-driven AI-based digital twinning approaches for as-is built environment. So how to generate it, the existing building information models for the existing buildings, and also then how to keep updated it during the operational maintenance phases. What I developed is this 3D Gaussian splashing SLAM framework for this built environment and through a multi-stage developed process. And I will show it one by one. Firstly, the static aspect. This is what I developed, an image-driven geometrical digital twinning generation approaches. So what I choose is easy collected algorithms and also easy collected data resources basic on the CAD drawings and also the images collected by the handheld cameras. So firstly, it is built the general frameworks basic on the CAD drawings, such as the columns, the beams, and also the overall structure layout. And the basic on the layout, and use the cameras to fit in the different images and also fit in the different objectives. So I developed a novel object recognition algorithms basic on the first AGNN and supported the object recognitions and also transfer the objects from the basic informations basic on the FC industry foundation classes algorithms to transfer all of these objects into a machine understandable, especially the beam standard based the overall models, and that can be directly used for the existing buildings. And further, the step is as this. So basic on the CAD drawings to construct the overall structures, and then use the images, especially the automatic object recognition algorithms to detect the different objects such as the windows, ceilings, walls, and different objects such as the cars and other expected and combined with the FC schemas to create the existing buildings. So it is a very practical, efficient, and also accurate as is building information model construction process, and also can be used for the further updated algorithms. And I also have a very practical examples for this part. So which is one projects that I lead as a PI maybe three or 4 years ago, and which is supported by the ICE, the Institute for Civil Engineering in the UK. And we hope that we can create kind of a lightweight carbon footprint decision-making digital twins for the highway operations. So it covered two aspects. Firstly, how to use the existing images and what data resources that we have, and to generate the accurate digital twin models. So which is not only including the geometrical part of the whole highways and the whole roads, but also including the materials, especially basic on the UK standards. And the second part is how to basic on dynamic data, such as the travel behaviors, and then to generate the daily carbon footprint consumptions, and then provide a kind of a carbon footprint decision-making platforms, basic digital twins for the highway England. So I have a video to show the overall digital twin platform. So we have three modulars. The first modulars is for the static one, for the highway itself. And the second modular is to combine the traffic footprint, especially the daily behaviors. Try to optimize and analyze the carbon footprint for the highway operation, based on the vehicle types and also their behavior. And also, we analyze the traffic influence for the whole systems based on digital twins and carbon footprint stage-based analysis method. And in the future, I hope that I can extend these projects combined with climate change and weather change simulations. So this is the whole systems that I developed for the carbon footprint. This is a very good example that combines the static and dynamic aspects of the digital twin for my research part 1. And for the part 2, I developed the 5-layer multi-scale digital twin series and people-federated digital twins. So I create this fed people series digital twin systems from the different levels, especially from the built asset to city levels, and also combined with the social technical series and perspectives. So it actually has 3 enablers from the data resources, data management with the 6 functional components, and also the data consumptions. So firstly, I developed a 5-layer multi-scale digital twin series and provide how the digital twin should be look like and the link with each others from the different levels, from the built assets to the city levels. The second one is build connections between the digital twins and also the human, especially the people perspectives. So build a real bidirectional relationships between the people and also the digital twin. The ways what I used is stakeholder requirements and data requirements, common data environments that provided for these people-based digital twins. And also I created this federated digital twin systems and proposed from the social technical perspectives. So I will show that for the steps from one by one. So firstly, this is my 5-layer multi-scale digital twin series, a little bit long name, and all the detailed expressions and detailed explanations has been covered in my book, the digital twin in the built environment. So we make assumption that all the digital twins should be share the same 5-layer structures. So from the data question layers, transmissions layers, digital modeling layers, data model integration layers, and also service layers. So this is the city levels, but in the building levels and also build assets levels or infrastructure levels, we hope that all the digital twins share the same 5-layer structures. So, and also through build a link through the different like the digital twins and also sub-digital twins, and build the whole city systems as a whole systems. So that's what we hope for the city digital twins, and also even for the Earth digital twins or nation digital twins. So based on the Gemini principles that I used to work with when I was a research associate at Cambridge, and we propose that this digital twin should be open to all the new concepts and share the same structures. So from the data questions to the transmissions layers, and such as IoT enabled awareness sensor networks, and also how the data can be transferred from the different levels, such as within the buildings or outside of the buildings, and also combine with the first part. So how to create kind of digital twins from the building levels or from the city levels, and then to how to base the new algorithms, develop the AI based algorithms, and combine with the model developed, and to create the further services for the 5 layers, such as whether this digital twins is used for the transportation management, for the energy management, for the space, for the whole such as the healthcare digital twins, or different perspective. So it should have a purpose. And then came to how the digital twin should be linked with the people perspective. So we developed this proposed stakeholder and data requirements driven data ecosystems, where we analyzed around 1,000 digital twin case, especially city digital twin case around the world, and we try to analyze what kind of data requirements actually is needed for the digital twin constructions based on the different purpose. So we use the social network analysis and combine all the different perspective in strategic and also the operational categories, and in different perspective to analyze the data requirements. And then for the futures, we also develop this kind of, a little bit small, I'm sorry about that, but we develop this kind of platform that the data requirements can directly stakeholder requirements can directly transferred to be the data requirements, and the data requirements can support for the future development of the data ecosystems of the digital twins to build the directly link with the people and also all the digital twin layers. So that means the people can provide the feedbacks and their requirements to digital twins. The digital twins actually can fit for the feedback loop and also fit for the requirements from the people perspective. And so based on the previous studies, this studies is actually based on the 1,000 city digital twin projects around the world and covered around 25 years. So it not only in the UK, but we collected data from the North America, from the Europe, from the Asias, and we analyze each case, use the social network analysis and combined and summary all the analyze into the common data requirements that the models we developed try to build the foundations for the federated digital twin establishment. So currently, this part of database will be shared and will be opened. I hope that within these years, when our first Nature cities, the papers published, so the whole database will be shared and benefit for more research use in the future. And I would like to use another examples for the second part of my research, which is the West Cambridge campus digital twins. So it actually aligned well with the 5 layers series that we developed for the digital twin from different levels. And from the data transaction layers, and we link the digital twins from the built assets, such as the pumps in the plant rooms, to the building levels, and then to the whole West Cambridge campus, and link with different database, especially establish new database from the sensors and IoT networks, and supported 2 platforms. One platform is for the commercial purpose, and another one is for the research-based purpose. And it can support many different services and also different applications for the 5 layers of the digital twin, such as energy consumption management, transportation management, asset management, for the building level, the indoor environment monitoring, and also for the assets level, like the maintenance, analyze, and also the abnormality detection. So not only my series or the whole series has been used at the West Cambridge campus, we also try to use it for the medical resources analyze when we have the COVID, when we like from the 2019 to 2022. And also it has been successfully used in many practical projects, such as the WeHyport digital twins and the Galaxy Rain Engine the digital twins for daily operation maintenance, and also for the Martian Town digital twins for the city management. So came to the third part of my research. So I already have the platforms and how to develop the models of the digital twins, and also have the idea how the digital twin can be linked with the people requirements, always thought it as a stakeholder requirements. Then, based on all these new algorithms and technologies, how to protect all the city systems from the climate hazard chance, and use these dynamic people-centric road flood user chance digital twins, and then further towards and express wider city systems, such as not only focus on the road networks, but also focus on other city systems. For example, I will show that later, the drainage systems. So this part of my research covers three perspectives. So how we can integrate all these complex nature systems and infrastructure systems into one, like what we call it, the chance digital twins. And then how to analyze and predict and also give the evolutions analyze based on the chance systems, and then how to predict and how to analyze, define the synchronized systems. So firstly, we involve a new concept, which is the network's resilience. So we always discuss resilience in different three-stage ways, but we hope that we can treat the city systems, especially road network systems, as a whole scale and systems. And the second, we provide a set of AI algorithms to support from the traffic predictions and analyze the complex infrastructure systems to define the synchronizations, and then develop the people-centric road flood user chance digital twins, and also collaborate with the Daphne systems in the UK. So the whole my systems about the resilient cities based on digital twins covered four perspectives. The first one is coupled human nature's infrastructure systems and combine all these complex infrastructures into the whole systems. And the second, develop the new algorithms, and I will discuss it in details later. For the traffic predictions and analyze how the different traffic mode can be transferred with each others. And the third is analyze synchronizations in transportation networks, and then virtualize and also developed the simulations and analyze the platforms based on the digital twins. So the first part is the whole chance systems, the complex systems integrations perspectives. So we analyze and also assess the dynamic vulnerabilities of the flood disturbed transportation networks, and for the one areas in London, and we choose that areas and combine different part of datas into the same systems, including the flood map, and also traffic flows, and also the social economy changes. And for the geometrical part, we combine the different data sets, such as the road networks, rainfall data, and also the buildings and also road networks. And we also and we also try to interviewed several groups, such as the London resilience groups, such as the TfL, and we hope that try to set a kind of benchmark that we can build this kind of link with the resilience target that is true aligned with the government. And then combines with all these data sets, we provided synchronizations and also vulnerability index series in these choosing areas and propose the 10 variant vulnerability index on this whole cities and try to predict where is the vulnerabilities and how it will affect it in the future. And the second part is we developed the new algorithms that can predict the traffic flows, especially under the climate change environment. So it covers three perspectives and paths. So the gen and modulars can effectively capture the complex, the whole structure independence within the urban traffic networks, and the field effect modules can simulate the overall generations of traffic impacts across the whole networks. And also the most important part, the pins modulars, the physics-informed neural networks can cooperate with the fundamental traffic flow principles and provided the data and the traffic flow predictions, especially even with very limited data. And this has been tested around the 16 cities around the whole Europe, and also not only in the London but also in the other different cities. Our algorithms and our systems show very good accuracies. So it is achieves around over 17 predictions accuracies, and even under very heavy rains and this kind of situations, and also can maintain a very outstanding prediction accuracies under normal conditions. And also it can perform very robustness, like even the conditions is very data limited. So our models actually can provide very high accuracy predictions, even with the data is quite limited, inefficient, and also different areas, different cities, and especially the most important different forms of road networks. And the third part is also it can be aligned with our target. We hope that we can develop a kind of new system, new algorithms support the accuracies and traffic predictions, even with the climate change conditions. So it can keep the high performance even under the different levels of rainfall, such as heavy rains and urban floodings. The second part is we try to develop the second part sets of algorithms which can predict and analyze how the different data models, especially traffic mode, can be exchanged and also have the effect with other traffic mode. So very thanks for the support from the Daphne system, especially the Daphne funding projects, and also the another professors from the CEGE, Professor Tao Chen, and she support and collaborate with me, focus on one projects that focus on this particular problems. So how different multimodal traffic data can have the interactions and effect with other like traffic mode. So how the traffic mode can be transferred or changed under the climate change or urban flooding, like this kind of situations. So what we propose this kind of a new analytic frameworks that can capture the non-equilibriums characteristic and multi-levels like data interactions of transportation systems during the urban floodings and extreme weather events. So thanks for the support from Professor Tao Chen. We have the very huge groups of data, especially in the Londons, and we also classified all the different part of the data into different mode, such as the walk, cycle, bus, and cars. And we basic on the analyze the framework, we can understand how this kind of different mode can transfer from others, especially under the different flooding, urban floodings. And for the urban flooding analyze, what we use and what we propose and collaborate is from another professor, so Professor Qiuhua Liang, and provide, Loughborough universities provide the high-pings models. So I always said I'm standing on a lot of giant shoulders, so to support my research. So especially from the data perspective and the flooding analyze perspective. So, and the third part is develop the novel symbolic dynamics systems to analyze how this kind of different systems can transfer and provide the future evolution mechanisms for the traffic flows, especially under different flood conditions. This part of research haven't been published yet, but it's under reviewed by one of the very top journals. But we try to analyze how this different networks nodes and properties and the transaction patterns and understand the mechanisms behind them. So I will always like have this kind of ambitions for myself and also for my groups, members, PhD students. So I hope that they can not only develop something that is very easy to use, but also like discover the true algorithms and the mechanisms behind them. This is can be go back to the first page that I show. So I always have two research questions and scientific questions in my mind. So what is the true algorithms and the true mechanisms behind them? So this is our first part of a platform, digital twin platform. I will show my second part later. This is purely for the traffic part. So how to, from identifying the vulnerability, analyze and predict the traffic flows, and analyze how different traffic mode can be transferred and interactions with each others, and then how to define the synchronizations in the transportation networks. So the whole systems. So this is our digital twin platforms. This part of the source code has been uploaded to the Daphne systems. If you search impact projects, you will get all the code and the data. So this is also thanks for the support from Daphne. This is the whole system. I will be a little bit quicker. So it's covered all the steps, like choosing this kind of London areas and analyze the vulnerabilities, and also came to the different paths and traffic analyze from the time and the spatial analyze. Speed up a little bit. And identified index of vulnerabilities. So please feel free to check the data and the code resources from the Daphne system. So, and another thing is, even though that some of my research, especially my PhD research, actually basic on 13 cities around the world, but we actually open 41 city data sets, including the urban traffic and also the flood around the world. And this has been published in the scientific data open to all the researchers. So if you have this kind of share the same research scope with me, or if you would like to do this kind of research in the future, please feel free to search the integrated urban traffic flood data sets and feel free to use it. And I hope that my research journey can encourage you, and our research resources also can benefit to all of you. So came to this stage. So we talk about like a digital twin, how to create a digital twin model, and we talk about how to link the people requirements with the digital twin and build a very foundations common data environment for the whole digital twin and also for the whole resilient cities, and then came to the future and also combine with the AI and how to create a resilient traffic flow or resilient road networks. So how we can start how what can I say? So basic on all these kind of foundations and what we did. So how to transfer from the transportation systems to the whole city systems is my next step and also my ambitious. So I hope that I can build on these shared systems, the coupled human, nature, and infrastructure systems, and basic on what I did for the digital twin areas for over 10 years and create this kind of one city systems. So what is mean by one city? It is the kind of a human-centered, AI-driven, multi-hazard and cross-domain, like whole complex systems. Of course, this is my ambitious. What I'm currently achieve is the transportation aspects, like what I just showed it to you. So how I can like integrated the city system different domains through the transactions, sensing the cities, and how to combine the different kind of city assets and the foundation support the future one city common data environment, and also then how to combine all the data requirements, not like one city digital twin by one city digital twin, but also from like higher levels to support and develop this one city digital twins, and further for multi aligned with multi like policy guidance benchmarks such as SDGs is my ambitious and also research future research journeys. So one very sorry one like a try for this kind of one city systems is I involve the drainage systems into my previously road traffic and flood digital things. This is also kindly supported by Daphne systems as I'm the Daphne fellows. So I add drainage systems of of the whole London areas into the previous digital twin cases, and let's see how this kind of pre-event, pre-flood event, and post-flood event vulnerability analyzed and how it can affected the whole cross-domain problems combined with the drainage systems and also the road systems. So this is our current initial results. So this is, as I mentioned, this is basic on the previous research. So basic on the traffic one. So you already familiar with that. I show it like 2 minutes or 5 minutes ago. And then this is how it integrated with the drainage systems, how the drainage systems, when we involve drainage systems, how it can be affected the vulnerability of whole transportation networks. I will also show it in a quick way. So it's to it is actually capture the real time the rainfall data from London Met Office, and how it this kind of part is how we analyze different road segments based on the drainage systems. So I hope that I can achieve my research ambitions step by step. So, basic on all my research, I hope that I'm not stop at one city level or like in the UK level. I hope also explore how the whole world will be look like, the global levels. So from the city to the global levels. So in order to analyze the multi-hazards and also the whole resilience coastal cities and the multi-hazards, we do several tries. So firstly, we analyze how the resilient coastal cities will be look like, especially under multi-hazards. And we also hope that we established the whole city digital twins, one city concepts, how it can support for the future city development, especially aligned with SDGs. So all these papers has been submitted to Nature series journals under review currently, and one has been published in Nature Sustainabilities. I hope that it can be online very soon. So this is all my research, and I'm open to Eileen questions and Eileen comments, and also hopefully collaborations. Thank you. Thank you.
Thank
I
you.
will
Yeah.
check the questions.
Yes, there are a few questions in the box.
Chat.
Yeah,
Oh.
I will allow our participant to speak. Sorry. Oh, yes. There are two questions from Shmuel. Would you like to speak, introduce yourself, and introduce your questions? Shmuel, can you hear me?
Maybe I
To
can
me?
read it.
Yes.
You
Hello.
hear me?
Yes, please.
Okay, thank you very much. I have two questions. My first question is how coupling between human nature and the infrastructure systems can support resolution problems of poverty and social and economic inequality in the cities.
Thank you so much for these questions. So, to be honest, I haven't analyzed or studied this part, but I believe that this is really important. I know that one of my very excellent colleagues who is status, so also the directors of Global Resilience Center, Global Center of Resilience. So the new centers that I established within our school, and I believe he touched some perspective from these areas, so like social and economy equalities. But I do think this is really important. If I have some when I finish my my plan is from the transportation to the drainage systems and then to the energy and also the electric car some perspective. So when I touch these key areas, I hope that I can go back to these very fundamental questions like the social and economy in the cities. Thank you so much for these questions.
Yeah, and my another question, this is it according to your opinion coupling between human nature and the infrastructure systems can support effective development urban agriculture?
Thank you so much for the question again. I think this is also very, very important questions because I know that a lot of researchers focus on the urban agricultures and also urban development and also urban extent areas. So especially at UCL, we have CASA to support all this kind of city like urban systems research questions, but currently I haven't covered it. But thanks for the suggestions. I will do cover it in the future.
Thank you very much.
Thank you.
Thank you, Shmuel. Okay. The next question comes from Richard. Hi, Richard. Would you like to speak? Would you like to introduce yourself and your question?
Hello, can you hear me?
Yes, please.
Okay, so Richard Hughes, consultant at Arup. It really extends from the previous questions about the social aspects, that people and cities are organisms that have tangible aspects to them, but they also have intangible aspects to them.
Yeah, sure.
Which are equally important, or indeed more important. The tangible aspects are things which can be transitory. Intangible tend to last for much longer periods, and hence a lot of our heritage is to do with intangible culture. And I feel that there is a need to capture a lot of the metrics and the parameters, integrate the parameters that capture intangible culture of people, the way that people work, operate, don't operate, etc. I think that's highly important.
Yeah, exactly. So when I established this Feed People digital twins is from a technical perspective. But when we analyze and I also establish the global city digital twin data case bank. When we establish that we do cover these questions. So we hope that I fully understand and I fully support agree with what you comment. So not only like a technical part, like the infrastructure part that is important, but also the culture aspect and also intangible culture aspects also valued. So when we establish the city digital twin case bank, we do cover some aspects from this side, and we also cover different region, different areas, and also different economies, and also different, like what you mentioned, different culture part to analyze the whole problems. So I hope that this study can be published very soon, and I can share that I can open that database and benefit for all the researchers. We do cover over 1,000 city digital twin cases around the world, covered 25 years for the past 25 years, and not only for the literature review from different papers. We do interviewed many different cases, one cases by cases, and it covers the whole studies covered over almost 4 years. So we hope that we can open it and share with all the researchers, all the consultants, all the people need that, and we can discuss it together, how it can be look like.
Okay, I think that's fine, but I do go back almost to a basic question: is what are your data sets? What will be your data sets for one city? Never mind 1,000 cities for the intangible cultural attributes. Where will you get your data from, and how will you compare the cultural attributes of a culture, say in the UK, from say one in China or one in Australia?
Thank you.
Where is this data coming from, and how will you integrate it and compare it, and differentiate it? It does seem to me that you need perhaps involvement of an anthropologist or a sociologist, and even and other skills as well.
Thank you so much.
Particularly psychologists would be extremely useful.
Yeah, thank you so much. So currently,
defining people. Once you start talking about people, I do feel that you got to capture these subject matters.
Yeah, exactly. So the whole part of the research from the people perspective integrated two aspects. So one perspective is from the project level. So project level is very easy to define. So how many stakeholders and what kind of group of stakeholders involved into the whole digital twin project, and what is their purpose, and what kind of service they provided, and what kind of people involved into the whole project. That is really easy to define because they all that is stakeholder aligned with the city digital twin people. And for the questions that how we collected data, as I mentioned, this projects have been lasted for over 4 years. In part of the data is from the literature review, from the data resourcing, and part of the data is from interview. So we have a list of interviews and collected and understand how this happened. So this is how we collected data and combined the data. And another second part of the people-related research is actually from the global level. We may not compare them in that detailed way that you mentioned, but we compare in a kind of like global south, global north, and the different areas, European, Australia, some like that. And that's a good point that we can further compare it in such a detailed way. That is a very good future studies. If I go further in the future. Yeah. Thank you so much for the questions.
Thank you.
Thank you.
Thank you, Richard, and also thank you, Chu Chen, for your answer. So I see one raised hand from Azar. Yes, now you can speak. Would you like to introduce yourself and your question?
Me now?
Yes, please.
Thank you. Thank you for this lecture. First. Second, my question is about that. Is it possible for the digital twins in the residence cities that if there is any problem or unexpected events in the infrastructure, give us indication to start protective or corrective or predictive maintenance for this type of problem that happen to the infrastructure? Is there any systems that recording that kind of maintenance through sensors?
I'm not sure if I fully get your questions, but you mean that digital twins can transfer or support for maintenance functions?
Yes, to give us indication that if there is some unexpected events happen in such of infrastructure, is the system of digital twins give us some indicators that need for predictive maintenance or corrective maintenance, and what kind of system that can we manage it to protect this infrastructure?
Thank you so much for the questions. Currently, what my research has been covered or has been done for the infrastructure is purely focused on the road networks, and especially to predict the traffic flow under the climate change, under the extreme weathers, like the heavy rain or this kind of hazards. So this is my key focus for the digital twin predictions, and also for the analyze perspective. So, but I have heard and also attend many different lectures that they use the digital twins to predict the performance, such as cracks of the bridge, or predict or analyze the maintenance performance of railway. Some research like that, but that do happen like around this kind of academia world or also industry areas. So my answer is definitely yes. So it can support for maintenance and also predict performance. But my research area is not in that direction. Thanks so much for the question.
Thank you. Thank you.
Thank you.
Thank you.
If there are no other raised hand or question, I have a question, Susan.
Thank you, Dina.
About you mentioned the predicting the effect of flooding on the transport network. And you also mentioned both accuracy and robustness. Can you go a little bit more in detail on the technical aspects of this? How do you, what is your benchmark reference? How do you measure the accuracy and so
on? So I believe it's this one.
Yes, this one or the one before even, yes.
Yeah, so the also the whole research of this part, so create a kind of resilient transportations, is covered by many different projects. So not only like supported by one part by Daphne and one part by another projects. So I combined all into the same page and stories. So this is the second functions of overall resilience cities. So the first one is to identify the vulnerabilities of the road networks. The second part is to predict the traffic flow. So I'm not predict the floodings. So my flood model, what I used for the flood model is the Haiping's system supported by Professor Chu Hualiang from Loughborough University. I directly get all the source code and support from him. So for the flooding perspective, what I use is his model. So, and what I did is use his models and from the flooding perspective, and combine with what I developed, what we developed, my research group developed the pins, gene, and algorithms to predict the traffic flow. So, how the traffic flow will be under the early flooding. So actually, the key part, what I did is the traffic flow, not the flooding. So
yes. But
yeah,
how do you said that you determine vulnerabilities. So what vulnerabilities do you measure? What are these vulnerabilities?
yeah. So firstly, what we did is we developed this kind of index to predict and analyze the vulnerabilities from the two areas, from the time and spatial areas. So with the arrows get larger, and that means this vulnerabilities is like high risk. And also with the arrows become shorter, that means the low risk. So this is what an index we developed to analyze the vulnerabilities. We also covered different time. So from the peak times in the morning and also to the late afternoon. So this is the vulnerability perspective. And so for the technical details is as you can see, firstly, we combined and integrated different data resources. So, covered into different perspective. So one from the how it will affected from the flooding, like a speed and flooding map. And another one is directly through the road networks perspective, how it will become the congestion risk. So how it will become congestion in the future. So this is how we evaluated for the surface traffic flow. This is the vulnerability perspective. And when we have how the vulnerability will look like for the whole road networks, and then we predict the future, predict the traffic flow as a whole. At this step, we haven't divided all this traffic flow into different mode, and we just treat the traffic flow as a whole, rough traffic flow. And we tested different data sets to benchmark our accuracy. So this data set is part of the data sets I mentioned here is our team created. So we created 41, but we use 16 here. So we use the London as a test and as a experiment, and also use other cities compare with experiment to get the accuracy and data. The data set is all what we done and saved in our groups. So in the London data is from the Professor Tolchin from CGE. And the next step
and
is
the data sets are about traffic flow per hours or traffic flow per minute, and you have it for each element of your network, or you then integrate between. You have it at different points, and then you sort of integrate and interpolate.
For the data, for instance, for London, what we studied areas. So from the King's Cross to Farrington, let me show. This is the London part we have. So as you can see, this is the target area that will focus on London area because London is so big, and we target the areas from King's Cross to Farrington. So this is our study area. So what we have is different part. So as we can see, this is the whole data structures of these data sets. So firstly, for the London part, thanks to Professor Tolchin, and we have a lot of multi-data. So we have 4 mode, the cycle, the bus, the people, and also I think different mode, 4 mode, and traffic data. And that is, if I remember it correctly, is 10 minutes. I think I read 10 minutes. So for the traffic, yeah.
So it's very detailed. Okay.
Yeah, for other cities, it's not that detailed because we covered 41 cities. We combine a lot of existing data sets in Europe. So, and also query the data from some existing, like Digimap, like open data resources, Digimap, something like that. So some cities may not that in details as London. So currently, London is the most detailed studying
Detailed.
area. Yeah. Yeah, very
Okay.
detailed, and I cover a lot of
And
detailed
can you
data.
can you use this in a forecast mode as well as an analysis mode?
This is our like future direction. We hope that we can analyze the pattern and the mode. So, but currently, came to this stage. This is all what I have done.
Thank you. Thank you very much.
Thank
Very
you.
interesting. Thank you.
Thank you so much, Tina. Session, I think there is a
there are two more questions in the
Good.
Q&A box, but the first one is great in Chinese. Okay, I will try to translate it into English, although I think that some also I think I made some difficulties to understand the Chinese. But I think the the key point is there are two questions. One is so is there any criteria to determine the
cost, right?
Oh
Yeah.
yes, there's also one question about cost.
Yeah.
Exactly, and then the cost. Yeah, oh, please,
I
you
can
can answer it.
translate. Yeah, I can translate.
Yes,
So
please.
let me make a summary. So firstly, how to construct the resilient cities in a fast and low cost way. And if it no idea or no way to construct it in the fast and low cost way, what's the main reason? I think this is the first questions. So that's a very tough questions. To be honest, I haven't covered the policy perspective, especially how to construct it, but I did interviews with many groups, especially resilient cities in London and also the TFL. I do cover some part of that. And their purpose currently in the London, the resilient strategies is quite straightforward. Is first come, first closed. So that means if this road is like with flooding and has a congestion risk, and then we close it. So basic on our group's analyze, this is cannot be the best way to keep the whole road network resilience if this is first come, first close. So this is the strategies. So when we came to these areas, we need to analyze how to optimize the resilient network strategies. So this is currently what I do for this part, how to fast and optimize the resilience network. But low cost part, I haven't touched it. I don't want to confuse a lot of people, so I want to keep it like in the future that if any researcher here is this aspect, so maybe can get this answer. The second question from this excellent researcher is, how is there online standard for resilient city? I don't think so. A lot of resilience standards metrics developed even every day. I can, because I track these areas, I can see a lot of new papers came out every year. There's no unified standards for resilience currently. What is the aims? Next question is what aims of resilient cities? The aim is really important because we hope that our systems, because as you may feel that currently we're under the dramatic climate change age, so we experienced more hazards like typhoon, like the heavy rain, like the different hazards around the world, like the heat waves, especially in the UK. If you experience that, the train traffic is affected by all these kind of climate events. So we hope that our systems can provide services for people and if they meet these kind of challenges, they can recover very soon. and also maintain the basic performance, support lives, and also save lives in some emergency situations. This is very important for the city and also very important functions of the whole city. So this is my perspective and my opinion. And the next question is even tougher. It says, what is the aims of this lecture and the meaning of this lecture? Uh, the meaning and aim of this lecture, from my perspective, is I'm really happy to share my research with different people, different backgrounds, different area. That is my pleasure, and I always hope that I can support and encourage new ideas, and that is also the meaning why I want to be the researcher. So, and also I think from Dina and also Zaishang's perspective and also the whole group perspective, they hope that I guess hope to establish a very good and global networks. I hope my guess is correct. So this is aim. This is the answer. Thank you.
Thank you. Also, thanks to this attendee. Thank you.
Thank you.
And another comment from Chao Jun. I'm unable to turn on voice. Okay, so I'll make a suggestion here. Instead, one city is a highly ambitious vision, and Professor Liu's work is already very substantial. However, in future research, I hope greater consideration can be given to the coupling among urban lifeline systems, people, the natural environment, transportation, and extreme disasters. Otherwise, focusing only on the transportation system cannot fully represent a complete city. For example, systems such as electricity, water supply, and energy should also be incorporated. Urban lifeline systems are the skeleton of city, while people and the environment are its flesh and blood, and the skeleton should not be overlooked.
Thank you, Zaishang, to go through the questions, and then also thank you for the questions from Chao Jun. As I mentioned at the beginning, the presentation of my today's presentations covers all my past works. So, and the one city is my ambitious. And I cover the city system step by step. Currently, what I cover is road networks and transportation. And all my theory is basic on the 6 components from Professor Michael Batty at UCL, another giant like Dina. So I hope that I always say that I stand on a lot of giant shoulders. So basically, a lot of different theories and foundations. So I hope that basic on all these urban systems theories, I can cover step by step in the future. I think I'm already like I'm just like around my although I promoted last year, but I think I'm still like a very early stage of my career. I hope that in the next 20, 30, 40 years, I can slowly learn all this kind of experience from my model, my female model, my like Gina, like the Professor Chu Hua, like the Tao Chen, like the Professor Michael Batty, like step by step cover all this city system one by one. So this is my ambitious, of course, not achieve yet, but my ambitious. So thank you.
Thank you. Another question from Yuan.
Juan?
Juan, yes. Would you like to speak and introduce yourself? Juan? Can you hear us? Maybe I can yes, let me introduce this question. So let me read this. As this integrated network, it adapts to climate change. Does it have the capacity to organize and direct community management for its sustainability?
Thanks for these questions, and also thanks, Zaishang. So, organize and direct community management for sustainability. If we talk about sustainability, resilience and sustainability, they cannot be separated by some point. So for my research, just one project I showed it before, the ICE highway projects that cover the carbon perspective. So all of my other research or projects haven't covered the carbon footprint or the sustainability perspective. And my plan is I hope that I can focus on one area like resilient this part and try to produce more like new knowledge. But if you experts or do some research for sustainability, really happy to have a discussion or collaboration. Thank you.
Yes, one, Julio, it's okay.
Okay. And the next question comes from Ziyang. Ziyang, would you like to speak, introduce yourself and your question? Hi, Ziyang, can you hear us? Okay, maybe let me read this question. Thank you very much for your presentation. I noticed that you use many different types of data input in your framework. Could you explain the data fusion strategy in your framework? Thank you very much.
Thank you, Zeshang. So for these questions, very lucky that I'm still here this page. So the first challenges that for my resilient cities that projects is the complexities of the whole infrastructure. So if you want to talk about the resilient cities, you have to face the complexities of the infrastructure first, especially we align with weather data. What I did is rainfall data. So you have to cover the integrated the complexities first, and you need to divide it, all these complexities of the infrastructure into different pieces. And so it's really complex, but I will introduce from two perspectives. So firstly, from the rainfall, this data. So for instance, for London, for this city, what we use is from Meta office. So there is some open data for the rainfall data. So, and then for the road is what we directly correlate from Digimap. So this is a road network geometric part of that. So, and like for the hourly reading and also meanings reading, different cities we use different method. As I mentioned, for the London, we through the project collaboration to get the traffic data. For other cities, we combined all the data for the 40 cities is from the Europe data sets. So there's some Europe data sets that we integrated cover this kind of traffic flow. And in the UK, Highway England also open some data for that. So this is also can be used. So it's really complex, yes, but can cut into different pieces and link it through the, as you can see, through the IDs and also through the version algorithms through them and through the logic that how we analyze it. So please feel free to go through our scientific data, that journal. It's already published. So it explained all the data pre-processing method, integration method, analysis method, and we also show one example how to use it. So please feel free to download it. It's how to say, really proud to publish that. Yeah. Thank you, Zeshang.
Thank you, children. Also, thank you, Ziyang, for your question. Okay, thank you. Are there any questions? Yes, please, Dina.
Right.
Yeah. If there are no more questions from our audience, maybe we can conclude today's session. Yeah, a big thank you to Professor Qiuchen Lu for your so interesting and informative presentation. Also, thanks to every participant today for attending this webinar. So wish you a wonderful rest of your day, and look forward to seeing you in our next webinar in the 7th of May.
Thank you so
you.
much for the invitation, and also look forward all the successful in the future. Thank you.
Thank you.
Thank you, Qiuchen. Thank you very much for
Thank you.
giving us
Bye-bye.
this.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.